Today I'm going to show you how to install the EZ2130 on the BigTreeTech SKR version 3 EZ. So I'm also going to show you how to do sensorless homing, and I had to do a little bit of prep on the board for this because unfortunately using tweezers during the actual tutorial is kind of difficult, so I'll point that out in just a second. First of all, we have our X stepper, our Y stepper, our Z stepper, our E0 stepper, and our E1 stepper. Over in here we have a little tiny jumper that we use for sensorless homing. It's this size over here, and you're going to need tweezers to place that in there if you so choose to use sensorless homing. Otherwise you can use regular homing, but the tutorial will be slightly different if you do. So essentially you grab one of these and then you place it down inside of here. So I already placed one right here for the X stepper, so I'm going to show you on that one. So there's another couple of things that I need to point out, and that is power. Normally you can drive your power off your PSU right here for the board supply power, but now they've added an additional power source that you can do between 12 and 48 volts. But you'll need to move this jumper, if you change it to 48 volts, over to these two pins right in here. But for this example, I'm not going to show you how to do that, but I'm making you aware of that. So taking the stepper, you want to make sure that the actual writing on it points towards the power supply. So it's going to go like this into here, and make sure it's firmly placed inside of there. Then I'm going to place the actual motor connection over in here for the X stepper, and I'm going to connect the power supply that's currently disconnected. So if you haven't seen my first tutorial on the actual basics for this board, I marked these with black and red marker in order to make it simpler for me to see that I'm connecting it correctly for the power supply. So now that that's set up, I'm going to connect the USB, which is not going to function because we have it disconnected for the jumper that's normally over in here for USB. The reason I do that, whoops, I almost turned the board on. The reason I do that is so that when we're using this actual stepper, it doesn't reset while using the actual steps. That's why I'm leaving it off. So we'll power it through the regular power supply, but I'll show you what it looks like when it's powered via the jumper, even though this is an extraneous step at the moment. So if we place the stepper right here, or excuse me, jumper right here, it'll power the board. So I'm going to take that off because we don't need it for this particular tutorial. And now I got to find it, so give me a second. I guess this is a good time for the tweezers. There we go. So what we need to do now is pop out the actual SD card and place it in the SD card reader, which is right here. Then we'll place this in the computer, and you may hear a beep. Now we'll go over to the actual desktop, and as you can see right here, I have the VS Code environment. In my very first basics tutorial on the EZ, there's a link to how to install this correctly with Platform IO. So if you don't have that little alien, that means you don't have it installed. So to install the actual firmware so we can modify it, we're going to click on the Explorer, then open folder, then go to our downloads folder, and here's our extracted Marlin version 2.1. So we're going to open that, then the second one, then select folder. Inside the selected folder, I'm going to click on the Marlin folder, then I'm going to go to source, core, boards.h, and inside here I'm going to search on SKR underscore V3. That'll bring us to the EZ board right here. So we'll highlight that and copy it. We'll also note the actual chipset, which is the STM32H743VG. What that means is the actual processor on the board being the MCU. So I'll point that out real quick. It's referring to the writing on the chipset right here. So that's going to say STM32H743VG. That is subject to change depending upon chip shortages with Big Tree Tech and their production of the boards. So that may change in the future as it has on several other boards. So what we're going to do is we're going to go back over to the desktop. We're going to minimize core and source. We're going to go to configuration.h and we're going to search on motherboard, and we're going to paste in the one that we just copied. Next, we need to change the serial port to -1. And notice I'm using the actual port for the board. This is interchangeable with the serial port down here or down here. You can put any number you want in here, but I use this first one to connect to the board to keep it similar to previous tutorials. Anyways, next what we need to do is search on A4988, and inside of here we're going to look for the TMC2130 and copy that and then paste it right here. Next, we're going to search on steps_per, and this will bring us to the steps per. These are the default values. You may need to use RepRap calculator in order to compute your individual values, but in this case, I normally now just change these according to what I'm using. So I'll show you what I mean. If I go over to configuration advanced underscore or .h, pardon me, and search on 800, I'm going to have to search a couple of times here to get to this point. This stands for 1/16 of a step. It can go from 0 to 256th of a step. So I'm going to show you now, if you change this from 1/16, you're going to have to change the 80 to 160. And proportionally, you're going to have to change the 16 to a 32. If you want to change this to 1/64th of a step, you're going to change this 160 to 320. And then you're going to change this to 64. And that's so on and so forth up to 1/256th of a step. I recommend not going that high. Maybe 1/28th of a step is your maximum. But essentially, it's safest to stay somewhat low. So anyways, I want to show you now that sometimes when you're actually using the board, the actual homing will go in the wrong direction. So if you search on invert, you'll see down in here that the directions can be changed. So if your x-axis goes the wrong direction, you can change the false to a true, and that'll cause it to go in the other direction. You can also flip a DuPont connector that I'm using currently for my steppers, but you may have a different type in your case. Anyways, now that we've got that configured, let's set up the actual debug. So I'm going to search on TMC_debug, and I'm going to hit the control / on the line for monitor driver status. This is only to set it up. You can disable this or comment this out once you've configured it, but we need to be able to use the G code to see the status of the stepper, in this case M122. Now to set up Sensorless homing, we're going to first finish doing the TMC debug. So I need to do the second one, which is down here. So I'm going to hit control /. Then I'm going to search on Sensorless homing, and it might take 2 tries to get to it. Here it is. So I'm going to click on the line, then I'm going to hit Control// to remove the actual comment and enable this. Now on previous steppers for the TMC2130, the normal one, not the EZ2130, 8 worked fine. But in this case, this may not work, and I actually know that it doesn't work, but I'm going to show you the error so we can fix it. So there's a couple of errors I'm going to show you about now. So this is going to be somewhat interesting so you can know how to decipher issues that occur during compilation, or building is another word for it. So we're going to go over to platformio.ini. What we're going to do now is we're actually going to go to default environment. We need to set this for our chipset. So we're going to go to the INI folder. We're going to find our chipset, which is the STM32H7. We're going to find our default environment, highlight it, copy it, and as you can see, that's our default environment for one of 2 boards. So I'm going to minimize this folder. I'm going to go back to the platformio.ini. I'm going to paste it right here. And then I'm going to click the garbage can to clean. And we're going to fail on the build in a second. So I'm going to click on the build button and I'll show you the failure and how to decipher it. So normally you would recompile a second time if you see an actual error. In this case, there's 2 errors that I know of in here that I have to set. But the first of which we'll find out in a second. The second of which I actually forgot to put in, and that's on the advanced configuration. So this may work for a compile. Oh, there's the error. So as you can see right here, follow this up to the very first error. Then you're going to highlight this, copy it with the Control-C. First check in configuration.h by doing Control-F and then Control-V, and it brings you to the actual X stepper. So we need to change this from false to true. So I'm going to change this to true. And the other issue that I forgot to configure has to do with the TMC use software SP. So I'm going to search on with the Control-F SW_SPI, and that's a SPI being serial peripheral interface. So we need to remove the comment so we can use the software specified values rather than these. And I'll show you where these are actually stored if you were to do it the other way. If you go over to source, core, boards, source, then pins, find the chipset in here, which is STM32H7. You can see that there's 3 different versions of SKR, version 3. These 2 point actually to the first one being common. There's no difference between them, but they did it that way on purpose in case there's changes in the future. So if you scroll down in here, you can actually see the stepper values for the different SPI communications. So these are actually what they're talking about. So essentially, we're pointing to these with the first thing that we specified right here. So I'm going to rebuild this, and hopefully it'll build correctly this time. If it does fail on the first try, I'll hit the build button a second time just to make sure that everything's okay. But if there is an issue, I'll scroll to the top of where the first red thing occurred, figure out where that is in the code, correct it, and then build again. So while this is building, what you can do is watch it actually in the .pio folder for build and your chipset. And we're looking for like firmware.elf first. And then if that doesn't come up, we know there might be a failure, but if it does, we'll see firmware.bin thereafter. So just keep in mind when you see yellow, that's a warning. You don't have to worry about it. That is normal for things. It's only when it's red. So we're going to see firmware.elf in a second, then bin. There it is. So we'll click on this. We'll right click and go to Reveal in File Explorer. Now the previous file was firmware.cur. This was successfully loaded. So that's why it's been renamed from firmware.bin. So we're going to right click on this and we're going to send it to the E drive. So now you can see them both. If this is successful, this name will be the only thing with this date. If you ever want to reload it, you'll have to rename it to firmware.bin and then drop it in your system. So let's pop out the drive and install it into our configuration. So I'm going to plug it into here, and then I'm going to plug in the USB. It's not going to power the board. Then what I'm going to do is I'm actually going to power the power supply for the board. So I'll plug this in, and there's a second error I'm about to show you. So I'll show you what happens. In this case, we're going to have to go over to Platform IO, which is our test software. So I'm going to open that up, and in this case, I've already shown you a couple of times, but let me take you over to the screen. It already defaults to the actual USB number that's connected. You can always check that by doing a search for Device Manager, and then inside Device Manager, you can look to see what that port is. So let's try connecting first to see what's going on. It says it's connecting and now online. Let's do the M122. It says everything's okay there. So let's try and actually home this now. So what I'm going to do is I'm actually going to move 10 to see if it's working, then 10 back. Now I'm going to home, and you may hear a grinding noise. So that grinding noise will cause a failure in a second over in here, which will stop it from working. So we have to do a disconnect. Then we have to actually go over to the board, unplug it. This will power it down. Now I'm going to pop out this actual drive again, and I'm going to show you what I discovered, because the default value didn't work for SPI, being 8. So let's go over to the computer for a second. And on the computer, we'll go over to VS Code. Inside VS Code, we'll go to Advanced Configuration. We'll search on Sensorless Homing. If I can spell it correctly. And you can see that it's 8 right now. I discovered there was an issue with this particular configuration where 2 is the optimal value for this particular stepper. So I'm going to rebuild this real quick. Whoop. I'll show you actually in a second because I moved from screen to screen. But essentially we had to search for sensorless homing, and this was originally, if I Control Z, it was 8. So I just rebuilt it by hitting the build button down here. And so I'll shift it back to what it once was when it started building. It's actually a sensitivity of 2, not 8. So as soon as this completes, we'll go back over here and we'll actually send it to the drive. So it's just rebuilt. So I'm going to click on this, right click, and I'm going to say send to, or excuse me, reveal in File Explorer, then right click and say send to the actual drive. But before I do that, I want to show you what's on the drive as usual. You can see the time. This is just recently changed because you can see it was 4 minutes ago. So we're going to go back, we're going to right click, and we're going to send it to the E drive. So now we have the newest version on there. Now we'll go back over to the workbench. We'll pop this out. We'll plug it into the drive. And we'll power the board back up. And we'll try that operation again. So if we go over to Pronterface, what you can see in Pronterface is we just heard it reconnect. So we'll connect. We're now online. We'll do the G code. You can see that it's actually okay. So now we'll try moving the x-axis again. We'll move it 100 this time. Now we'll try and home. And you can see that it now is more sensitive. So if you like my tutorial, please press the like button and subscribe. And for my patrons that have subscribed on Patreon and see the videos early, thank you very much. I will place a thank you note for both patrons and people on PayPal at the very end of the tutorial. So everyone take care, be safe, and I'll catch up with you later.